let f of x be given as follows. It's a piecewise function or a composite function. And we want to know for which k. Now this is k if you cannot see it. For which k is this limit defined? The first thing we need to note is that if the limit is defined, so let's assume that the limit is defined. Then this would imply that the limit as we tend to x is equal to 2 of f of x is equal to f of 2. You remember the definition, it says that limit as x, let's say, tends to x naught of f of x is equal to f of x naught. So this is what it means for a function to be defined at a point and to be continuous there. So I'm just using the definition. This is by analogy. And here our point here is just 2. Okay, but what is f of 2? That's a really good question to ask. Well, in this case, if x is equal to 2, then f of 2 should be equal to k x plus 7. But at the same time, we would like to consider both limits. And what do we mean by both limits? So this is something I'll clarify right now. We need to look at the positive and the negative approaches. If you are approaching x is equal to 2 and you want to look at the behavior of the function, you can approach it from the left, so values less than 2, and you can approach it with values greater than 2, which is 2 plus something. And this makes a difference, because in the 2 plus case, if it's 2 plus, then it's greater than or equal to 2. Then the function is defined there. So it is indeed what we have here. It is kx plus 7. But if we take a look at the 2 minus limit, because the function needs to be continuous. So if x is less than 2, just by a little bit, then it falls in this category. Then it should be equal to the x squared plus 19. In this case, it's this, because the domain is different, and then we can plug in now. So if we plug in here, you get 2k plus 7, and below you get 2 squared plus 19, which is 23. And now I claim that these two are equal, just because the limit is defined. So if the limit is defined, more or less, then you have a function like this. Let's imagine, actually I think I can plot it myself, but I need to solve for k first. So I want you to believe that this is true for a minute now. And then if this is true, then k will be equal to 23 minus 7 is, I think it's 16, and divide by 2 you get 8. Okay, so if this is true, then you have 8x plus 7. It probably looks something like this. Something like this. until, let's say, this is x is equal to 2. And then you have x squared plus 19. Okay, that's not a function. Actually, actually it's 23, because that's where they meet, both of them. So that is the first part of the function. It's a linear function, and then you have something that looks like that. And if the function is continuous and the limit is defined at the point x is equal to 2, then it should be continuous, it should be smooth. I should be able to draw it without lifting my pen. And so the limits have to coincide. If the limits do not coincide from the left and from the right, then you don't have a limit. You have something, let's say, like this. Then there's a jump. Okay, let's say it's like this. That's not good. This is good. I mean, there's no good and bad, but this is what we are looking for. So if the limit is defined, then if you approach this from the left, it's the same as approaching it from the right. This is a common theme with composite functions. So once you see composite function, and you see that it is defined for a certain domain, and there's a point at which the function switches its definition from one definition to the other. Now, if the function is continuous there, then this limit should exist. It should be smooth, you should be able to draw it. And vice versa. If the limits coincide, so if at x is equal to 2, this is equal to that, then the function is also continuous. So it's an if and only if statement. So let's say I can give you an example of this. Maybe I'll put 9x plus 7, so I don't put 8. And then you're asked in the exam, is this function continuous or not? Then you have to look at the limit as x tends to 2, because this is a possible discontinuity. And then you take the limit here, you take the limit there, from the left, from the right. You get that actually, okay, this is not the case. I can, in that case, I think it will be, no, it will be the same starting point, but we tilted a little bit higher. So it will have a steeper slope. And if it has a steeper slope like this, if it's 9x plus 7, then they don't intersect. And then that's it's not a bad thing, but you need to know what you're doing.